Hello friends, let us today discuss about what is modulation and what is amplitude modulation. So first, let us understand the process of modulation and some of the terms which are associated with this modulation process. So it is basically the modulation is the process of varying one or more properties of a high frequency periodic wave which is known as the carrier wave, and this variation is produced in terms of the instantaneous values of a low frequency information bearing signal, which is basically the message signal or also known as the baseband signal. And this modulation process is actually done so as to transmit efficiently the message signal over a long distance through a communication channel. Now the question is that what is a channel? So we can define a channel, a physical medium which have a specific frequency range that adds noise and loss to the message during the communication process. Here are some of the terms which must be clear for us. So the first term is a message signal. So this is actually the information which we want to transmit over long distance. It is in fact a low frequency signal, normally an audio signal. It may be speech, it may be music, it may be voice or something else. Now the wave which is used to transmit this message signal is the carrier wave, which is a high frequency constant amplitude sinusoidal wave. It is a radio frequency wave. It is very high frequency. It is having high frequency, and compared to the frequency of the message signal. Now message signal is can be defined as low frequency signal that carries the information, usually audio, but can also be video and digital data. Then the superposition of message signal over the carrier wave produces a wave which is known as the modulated wave. So here three things are to be understood. First one is the message signal, which is a low frequency signal. The other one is a carrier wave which is used to transmit the useful message signal. This carrier wave is a wave of high frequency, and the resultant or the superposed wave of these two is known as the modulated wave, which is the wave which is to be transmitted through the communication channel. Now the question is that what is the need of modulation? Why we do modulation? So there are certain factors because of which we have to modulate the message signal before transmitting into the space. The first one is the size of the antenna. First consideration we must take into mind is the size of the antenna. If we directly transmit the message signal, then the height of antenna required for this purpose will be very large, which is not practically feasible, as the practical antenna height is of the order of lambda by 4. So for audio frequencies it will come out into kilometers. So to set up an antenna of such a great height is practically impossible, almost impossible. So that is why we do not directly transmit audio frequencies or the message signal into the space. The second thing is that long distance transmission needs that the waves should have high energy, whereas the low frequency baseband signals or the message signals are of low energy because of their low frequency, as the energy of wave is directly proportional to the square of the frequency. So message signal or the baseband signals which have low frequency are also of low energy, and since during the transmission process there is attenuation or the loss of energy, so these signals are not capable of being transmitted to long distances because of their lower energies, which is the result of their low frequency. And the third consideration is that the baseband signals or the message signals have frequencies in the same band, 20 hertz to 20 kilohertz. So if the same frequency signals are transmitted from different transmitting stations, then there will be mixing of signals, so nothing will be clear at the receiving end. So so to avoid signal mixing, carrier waves which have different frequencies for different transmitting stations are used for this transmitting purpose. And fourth point is that modulation improves the signal to noise ratio. Noise is any unwanted electrical things or electrical voltages pickups which automatically superpose over the actual or desired signal. And since the original audio signal might be very weak, so the noise may be comparable to that signal, so signal to noise ratio will be very small in case of unmodulated message. To improve the signal to noise ratio, we first modulate the message signal and then we transmit it to the communication channel. And finally, the modulation makes the requirement of equipments and equipments are lesser equipments and standard bandwidths makes the practical and cost effective transmitter and receiver hardware because of the modulation. Now here I have made a comparison between the signal and the carrier wave. So it is very much clear from this message signal wave that it is a signal of very low frequency as compared to the carrier, which is a signal of very high frequency. In terms of different parameters, we can see here the frequency of message signal is around 20 hertz to 20 kilohertz normally, which is quite low compared to the carrier wave frequencies, which are very high. For amplitude modulated waves or AM modulation, this carrier frequencies are in the range 535 kilohertz to 1705 kilohertz, whereas for frequency modulation it lies in the range 88 megahertz to 108 megahertz. Similarly, we can see that amplitude of message signal varies with information. So before modulation, the amplitude of the message signal is not constant, it is varying with time, whereas for the carrier wave the amplitude is constant before modulation. Secondly, the message signal is actually the voice data or some kind of video which is produced by the original source, whereas the carrier wave is generated by a specific type of radio frequency oscillator, which is also known as a local oscillator. The message signal actually contains the information or the intelligence that we want to transmit from one place to other place, whereas the carrier has no information of its own, and the message signal cannot be radiated efficiently. It needs huge antenna to be transmitted into space, so which is not practically feasible, whereas the carrier wave, which is a radio frequency wave, and because of its smaller wavelength, the required antenna height will be quite small and will be practically feasible to make it possible. And then the role of these message signal in transmission, this is basically the modulating signal, and whereas the carrier wave is the wave over which the message is superposed. Now here I have listed the types of modulation. The first one is the amplitude modulation, for which the message signal can be represented by this equation, small bm equal to capital Bm cos omega mt. So here cos omega mt is the angular frequency of the modulating signal, and this Bm capital is the amplitude of the modulating signal. Where we have considered the initial phase of the signal to be 0, then amplitude modulated wave will look like this, in which the carrier wave equation is like this. This theta 0 is the initial phase and omega c t plus theta 0 is the total phase. Bc is the carrier amplitude. So the carrier amplitude, in case of amplitude modulation, this carrier amplitude, that is capital Vc, is varied according to the instantaneous value of this modulating signal. So we can see that here the amplitude modulated wave, that is the resultant wave, is given by Vc plus Bm cos omega mt. So the amplitude of the carrier is varying with time in accordance with the instantaneous value of the modulating signal. This can be represented like this. Here another one important factor is MA, which is known as the modulation index or depth of modulation also. So amplitude of the carrier is varied in proportion to the message signal. Frequency and phase remains constant. Modulation index MA can be given as the ratio of the modulating signal to that of the carrier wave amplitude. Now this MA always lies in the range 0 to 1, that is the modulation depth of modulation or the percentage of modulation can be between 0 and 100%. It can never be more than 100%, because in that case we will lose some information while transmission. So this Vm is always less than equal Bc. Vm is greater than Bc, then there will be distortion and we will lose information. Another important type of modulation is the frequency modulation. In this case the resultant frequency modulated wave is governed by this equation. Here you can see that this carrier amplitude is kept constant, it is not varying, rather the frequency of the carrier wave is varied in accordance with the instantaneous value of the modulating signal. So this Vc cos omega c t plus mf sin omega mt. So this carrier frequency is now varied. As the modulating signal is varying, the carrier frequency is also varying. So this is the frequency modulation. In this case an important factor is deviation ratio mf equal to which is kf Vm upon 2 pi and the maximum frequency of modulating signal. Here we can also define frequency deviation like this. So that is not the important thing. Here I have listed some important formulas and I also shown the amplitude modulated wave here. So modulation index MA is given by the ratio of the amplitudes of modulating signal and that of the carrier wave. This can also be represented as the Vmax minus V minimum upon Vmax plus V minimum, where Vmax is the maximum amplitude of the amplitude modulated wave and V minimum is the minimum value of the amplitude modulated wave. So here you can see that from this x-axis up to this peak, this is Vmax, and from this x-axis up to this point is the V minimum. So this is defining the modulation index, and this is always between 0 and 1. Now here I have shown that there is no useful power in the carrier. So carrier is just carrying the message signal. The useful power is not here. It lies in the side bands. These are the side bands. So these side bands have frequencies given by Fc plus Fm and Fc minus Fm. So Fc, what are the values of Fc and Fm? These will decide the range of frequencies in the lower side band and in the upper side band. So this is the lower side band and this is the upper side band. So useful power is lying only in this, whereas the useful message, and so some of the power is here also. So that carrier power is basically a wastage of power, because the useful information is either in the lower side band or in the upper side band. So we can see here some power relations I have listed over here. So total power PT is equal to PC 1 plus MA square upon 2, where PC is the carrier power and PT is the total power. Now the power in the side bands is given as PC times MA square upon 2. So this is the total side band power, and in each side band the power is half of this, so it will become PC into MA square by 4. So side band power divided by total power is equal to MA square upon 2 plus MA square, and the bandwidth for this AM transmission is the twice of the highest modulating frequency. So if we are given the modulating signal frequency, then we can easily calculate the required bandwidth for amplitude modulation. Here I have listed some of the advantages of amplitude modulation. It is a simple low cost, it needs simple low cost transmitters and receivers. Demodulation is quite easy using a simple PN junction diode detector or envelope detector, and a narrow bandwidth is required for this amplitude modulation. Longer range at medium frequency and higher frequency via ground and sky wave propagation is provided here. Some of the drawbacks of amplitude modulation are listed here as poor immunity to noise and interference. So noise is quite large in case of amplitude modulation. Power efficiency is also low because most of the power resides in the carrier, not in the side bands. Then another drawback is that amplitude modulation has lower audio fidelity compared to frequency modulation, and finally the signal fading is also occurs in case of amplitude modulation. Some of the applications of amplitude modulation are listed over here. For amplitude modulation, radio broadcasting, AM radio, then short wave broadcasting. I have also listed over here the frequency range for the carrier wave used in this case, and then for aviation also. And here I have listed some important problems, numerical problems, through which we can have a feel of how this modulation index can be calculated, or what is the ratio of powers which is lying with the carrier wave, or it is lying in the side bands. The first problem deals with the calculation of modulation index. This modulation index can be simply calculated by using this formula, B max minus B minimum or B max plus B minimum, and we can see that this modulation index is less than 1. So in terms of percentage, it can be said that it is 66.7% modulation. Then in the second problem, I have calculated the total power associated with this amplitude modulation. So unmodulated carrier wave power is given here, and depth of modulation or modulation index is also provided here. We have to calculate the total transmitted power, so it can also be easily calculated by using this formula. When in the third problem, power in the sideband, so total power is given, then we have to calculate first carrier power, and then finally we can calculate the total power in the side bands, that is PSB, and by dividing by 2 we can calculate the power in each side band, so which is quite small. We can see that 10 kilowatt of power is used here total, and the power in the each side band is only 1.665 kilowatt. So there is a large loss of power in this case, amplitude modulation. Finally, we are calculating the bandwidth in this particular numerical. So here the modulating signal frequency is 100 hertz to 5 kilohertz. So maximum frequency of the modulating signal is 5 kilohertz. So because of that, the bandwidth will be twice of this frequency. So that is the bandwidth will be 10 kilohertz. So friends, we have seen in this presentation basics of amplitude modulation and the need of modulation. Hope you will understand these concepts, and we will discuss some other things in the next lecture. Thank you.